Example 2. Let us, in this question, we talk about the line MN is parallel to the line BC. Angle NMC is equals to NCM. So NMC is equals to NCM. So we can say that they are isosceles triangle for the triangle MNC lah. So they ask us to prove that triangle ABC, the big triangle ABC, is parallel to triangle AMN. So how do we do it? So let us take a look. They ask us for this triangle. And this triangle. Okay, so we know that MN and BC are parallel. Okay, so let us consider these two triangles. We know that first, these two triangles, we have a common angle, and the common angle here will be angle A. Okay, so both have angle A. Write them down. A, B, C, followed by A, M, N. In similar triangle, the position also matters. So when we talk about angle A, right, for triangle ABC, we write down angle BAC. We need to write down angle MAN for the smaller triangle. Okay, so position matters, and they are equal because this is common angle. In similar triangle, as long as you can prove two angles are the same, we can use AA similarity test, and that would suffice to show that these two triangles are similar. So we just need to find one more angle. Since MN is parallel to BC, we can say that this angle here, AMN, is the same as ABC. So write down angle AMN is equals to angle ABC because of corresponding angles. Okay, so with these two, we can say that these two triangles are similar. So therefore, it proves that triangle ABC is similar to triangle AMN. There's no shortcut to similarity. We don't have shortcut. We don't write equal. We just write is similar to. So it's similar to this triangle, and this one is AA similarity test. Okay, this is part A. Next, for part B. Usually part A and part B, they link. So when we know that these two triangles are similar, we learn that their lengths are corresponding. So same thing, we are using this. What can we say about the length AB? AB, the corresponding length will be AM. Followed by BC, the corresponding length is MN. And lastly, AC, the corresponding length is AN. Okay, so what they want? They want NC times AC equals to AN times BC. Don't be scared by this question. So take a look at which length are they looking at. NC is not here. Okay, but don't worry. We have AC here. We have AN here, and we have BC here. Okay, so let us take a look at use these two fraction to solve for your question. Why are they equal? Because we can use that since triangle ABC is similar to triangle AMN. Okay, this one property that their ratio of the lengths are equal. So when we cross multiply this fraction up together, we are using BC over MN equals to AC over AN. We cross multiply them together, BC times AN equals to AC times MN. Okay, so next, what is MN? Take a look at the question. We have this in the correct position together because they want AN and BC together. We have AC together. How about NC? So we, in this question, right, they say that angle ANMC equals to angle NCM. So since angle NMC equals to angle NCM, they are equal. Okay, we can say that these two lengths are the same. Okay, we can say that MN equals to NC. So we can convert this into BC times AN equals to AC times NC. Okay, do rewrite it such that it's exactly the same position as the question. So the question say NC times AC equals to AN times BC. It's exactly the same, shown or proven. Okay, so that is example 2. Next, you can do the next example on your own. Okay, please do the next example on your own. Same, it is exactly about the same as example 2. For similar triangle, you might, in this case, you might want to use AA similarity test. And for part B is exactly the same. So we use the similar triangle and the ratio of its length to solve. Okay, so do it yourself at your own time. We'll move on to midpoint theorem. For midpoint theorem, we have in this triangle, so we have A, B, C. If DE are midpoints, DE are midpoints of AB and AC respectively, tells us that this length are the same and this length are the same. Okay, so what can we say when they are midpoints? We can say that DE is parallel to BC, and we can say that DE is half of BC. Okay, we can also say that because they are parallel, right? We can also say that triangle ADE is similar to triangle ABC. Okay, please remember to prove it before you can say that lah. Okay, prove that A is a common angle and one of the angles are the same. So this is the common angle and these angles are the same because of corresponding angle. So by AA similarity test, these two triangles are similar. Now let us take a look at the example. In this diagram, G, F, E are midpoints of AB, AD, and CD. They have actually marked out the equal lengths for you already. The line GE and AD intersect at point F. So how to prove that AC is parallel to BD and it's also parallel to GE? So first we take a look at the triangle AGF and the triangle ABD. Okay, so we know that since AF equals to FD, AF equals to FD, AG equals to GB, we can prove that GF is parallel to BD. Okay, this one is midpoint theorem. Okay, so we use the midpoint theorem whereby these two triangles, where G and F is the midpoint of both length AB and AD. So we can prove that these two GF is parallel to BD. Next, we take a look at another triangle. The next triangle that we take a look at will be this triangle. So let me erase them first. We will take a look at triangle DFE and triangle DAC. Okay, same thing, we will be using this triangle AGF and triangle ABD. This is triangle DEF and triangle DCA. Okay, so since we know that DE is equals to EC and DF is equals to FA, by midpoint theorem, we know that the length FE is parallel to the length AC. Okay. Okay, since point G, points G, F, and E lie on the same straight line, we can conclude that AC is parallel to the line BD, and it's also parallel to the line GE. Okay. Next part 2. Part 2, the question is asking for GE is half the length of AC plus BD. So GE, let me highlight for you the line GE. GE is half the length of AC plus BD, and we're talking about these two lines. Okay, how do we go about proving this? First, we need to make use of this part of the line first. So we need to make use of GF. Okay, note that GF and BD, GF is half the length of BD using midpoint theorem. Okay, same thing, using midpoint theorem, we know that EF is half the length of AC. Okay, so as long as your question gives you that this point is midpoint of the line, side of the triangle, and point D is the midpoint of another side of the triangle, we can prove this part here, whereby the line, the horizontal line, DE, is half the length of the base, which is BC. Okay? So same thing, let us use midpoint theorem to answer this question. Okay, right here, part 2. Okay. So, since AG equals to GB, this is given, and AF equals to FD, given in the question, GF is half of BD. This is midpoint theorem. Same thing, since CE equals to ED, and AF equals to FD, we can conclude that FE is half of AC. This is also midpoint theorem. Okay, so how can we find out the whole length of GE? GE is actually GF plus FE. Okay, so when we add them up together, GE equals to GF plus FE. It will just be half of BD plus half of AC. Okay, I'm using this working also. So I change GF and FE to half of BD and half of AC. And from then on, we can factorize out the half, and it's just half of BD plus AC. Please write it according to the question, AC plus BD, and that's how we prove it. Okay, so that's all for midpoint theorem.